Hello everyone, welcome to 𝗙𝗲𝗃𝗃𝗃𝗃 YouTube channel. This is 𝗏𝗏𝗃𝗃𝗃 and in today's video we are going to discuss the solutions for latest CodeChef contest Starters 168. Let us start with the first problem. So coming to the first problem, can you bench? Let us understand the problem statement. Chef goes to the gym daily and follows a progressive bench press routine. In the first set, Chef will lift X kilograms. For each subsequent set, you will increase the weight by 10 kilograms. Now, your task is to calculate the amount of weight Chef will bench in the third set. Now, the input format is the input consists of a single integer X, the weight in kilograms Chef benches in the first set, and the output format is we need to output the single integer, the weight in kilograms Chef will bench in the third set. Fine, this is the problem statement. So now let us understand the problem. Initially, the amount of weight Chef is going to bench is given as X. In our case, it is 10. This is on the first set. Now in the second set, if you observe, the chef is going to increase the weight by 10 kilograms for every subsequent set. For the next set, he'll increase the weight by 10 times. So in the second set, the value of weight is nothing but X plus 10, that is equal to 20 for the second set. Coming to the third set, again he will increase the value by 10 times, which is nothing but X plus 10 plus 10 equals 30 for the third set. Now the problem is to print the weight on this set. For any value of X, it is X plus 10 plus 10. That's it. Let us try to code it up. Let us code it up. So according to the input format, let us read the value of X. You will be given single line input X. Now as we have seen, the value is nothing but X plus 10 plus 10. Let us submit the code. That's it. The problem is pretty straightforward. Cool. Let us move to the next problem. Let us move forward to the second problem of the contest. 𝗏𝗃𝗃𝗃𝗃. Given n students standing in a row, each student I has a distinct achievement score AI provided in an array A. The array A consists of distinct integers from 1 to n. A student I will be happy if their achievement score AI is greater than the achievement scores of all the students standing before them in the array. The task is to print whether a student is happy or not. So let us understand the problem statement better by taking an example. So basically you are given an array A. This is the achievements array. So the achievements array is going to contain the scores of each student. So coming to the first student, will the first student be happy? Yes, he'll be happy because his score is greater than everyone standing before him. Since there is no one standing before him, his score itself is greater. So he'll be happy. Coming to the second person, will he be happy? No, because his score is not greater than everyone standing before him because of this 3. So he'll not be happy. Coming to the third person, will he be happy? No, because his score is also not greater than everyone standing before him. Same, because of this 3. Coming to the fourth person, will he be happy? Yes, because his score is greater than everyone standing before him. So he'll be happy. Fifth person, he'll be happy. Same, his score is greater than everyone before him. So this is the problem statement. Let us understand the input and output format. Input format. The first line of input contains a single integer t denoting the number of test cases. So you can understand the input format by referring to this sample input. So this is t, the number of test cases, and for each test case you'll be having 2 lines of input. So for each test case you're having 2 lines of input, and the first line of test case contains n, the number of students, so 5 students, and the second line of each test case contains n spaced integers a1 till an. So this is n spaced integers. So there are 5 spaced integers. This is A. Same with this. This is the first test case, this is the second test case. Let's see the output format. For each test case, print a single line containing n integers. Print ith integer as 1 if the ith student is happy, otherwise print 0. So refer to the output format. So we have taken the first example. So if you observe, if the student is happy, we need to print 1. If the student is not happy, print 0. 0, 1, 1. So this is the output format. Yeah. If you observe the constraints, the value of t is ranging from 1 to 4 into 10 power 5 to 10. A of I is ranging from 1 to n, and the sum of n over all test cases doesn't exceed 4 into 10 power 5. So what does this mean? Let's see. So you are given t is less than or equal to 4 into 10 power 5. For every value of t, you are reading n. Let's say you are reading n1, n2, n3, n4, so on. So according to the constraints, n value can be less than or equal to 10. So n can be 5, n can be 4, n can be 10, n can be 6, and so on. So according to this statement, this entire sum is less than or equal to 4 into 10 power 5. It is not like all the values of n are 10 itself. If you take like this, then this sum will be 4 into 10 power 6. You cannot have a case like this. So the values of n are something like this. So this is all about this statement. Cool. Let's move forward. So we have taken a test case, n is equal to 5 and a is equal to 3, 1, 2, 4, 5. So what I'll do is, we will, according to the problem statement, a student is happy if his score is greater than everyone on the left. So instead of going directly like checking whether his score is greater than everyone on the left, what I'll do is, I will check if there is at least one score on the left which is greater than the current student score. Let's see how we can move forward with this. Starting from the first person. Is there any student whose score is greater than the first person's score? No. So he will be happy. So I'll print 1 here. Next, coming to the second person. Check if there is anyone on the left whose score is greater than the second student's score. Yes, you have at least one person whose score is greater than this score. So he'll be not happy. Third person, check on the left, at least one student whose score is greater than this student. Yes, so he'll be unhappy or sad or not happy. So I'll print 0. Coming to the fourth person, check if there is at least one person whose score is greater than this person's score. No one. So he'll be happy. Fifth person, no one with score greater than the current student's score. So he'll be happy. So converting this logic into code, what are we doing here? We are first looping on the entire array and fixing the current element and checking on the left. So first I'm looping on every element on the array, then looping on the left part of the array, fixing the current element. Let us move to the coding part of this problem. So we'll start by reading and iterating the number of test cases, reading the size of the array, then the array, next for every element we'll check if there is an element on the left which is greater than the current element. So for that we'll iterate on the entire array. Then let us fix the current element as a of I. Next, we will iterate on the left. Before iterating on the left, let us have a flag variable stating that there is no element on the left which is greater than the current element. So we will initialize the flag to true, means no element on the left which is greater than the current element. Then we'll iterate on the left. Now, if you find at least one element on the left which is greater than the current element, we'll simply make our flag as false. Once the flag is false, there is no point of checking for the rest of the elements. Now, for every element, we need to check if the student is happy or not. So for that, if your flag is equal to true, if your flag is true, then the person is happy, else the person is sad, not happy. For every array, so we got the expected output. Let's submit it. That's it. Let's move forward. Let us continue our discussion with the third problem, make odd. So, coming to the problem statement, you are given two binary strings A and B, each of length n. Okay. Your task is to make your score odd, which is initially 0, by choosing n elements such that for each index I, you will select either AI or BI. If the character you select is equal to 1, add 1 to the score. If the character is 0, add nothing. So basically, you are having two strings A and B, two binary strings. Binary in the sense 1 and 0, a string which is containing ones and zeros. So these are the two strings, and there is some score which is equal to 0 initially. Score is 0. You need to make this score as odd by picking an element from either A or B. And if you pick an element from A or B, if it is 1, if the character is 1, then you will add 1 to the score. If the character is 0, you will do nothing. Got it? That's what this problem statement says. And your goal is to determine whether it is possible to make the score an odd number. If it is possible, print yes, otherwise print no. So you know how to take the scores, how the score is getting incremented. So the problem statement is to determine whether the score can be any odd number or not. Let's move forward. Let us understand this example. We'll see whether we are going to print yes or no for this particular example. Let us start. So initially our score is 0. Now we'll start from here. At this point, are you having any option of taking 0 or 1? No option. So obviously you should pick one from A or one from B. So your score will get incremented by 1 time. Next, moving forward. At this stage, do you have any option of picking 1 or 0? Yes. So which one will you pick? Make your score as odd. You should pick 0. So you'll pick 0 and score remains odd number. Now at this stage, you have two options, either picking 1 or 0. So what will you do? Your score is already odd. You need not pick anything. So you'll pick 0. You need not increment your score. So you'll pick 0. So your score remains odd. So first we picked 1, second we picked 0, third we picked 0 again. So your score is odd. So we are able to make the score as odd. So the output is yes. Fine. Let's move forward to the second example. Again, your score is 0 initially. Now at this position, do you have any option of picking either 1 or 0? No option. Obviously, you need to pick 1. So 1 is being picked. Score is incremented by 1 time. Now at this position, do you have any option of picking either 1 or 0? No option. So obviously, you need to pick 1. So your score is 2. So there is no option of making your score as odd number in this case. Right? So the output for this particular example is no, and the output here it is yes. So the same thing in the sample input and output, sample input and output. Fine. Let us move forward to the input and output format. So the input format, the first line contains an integer t, the number of test cases. So this is the number of test cases, and for each test case, first line contains integer n. So this is n, the length of the strings a and b, and the second line contains n characters representing binary string a. So this is a. Third line contains b. So this is the input format, and the output format for each test case, output a new line yes if it is possible to make score an odd number, and no otherwise. So the output is of size 2 because the number of test cases are 2. So for every test case, you are either printing yes or you are printing no. So this is a sample input and sample output. And coming to the constraints. So constraints, t is greater or equal to 1 and less than or equal to 3 into 10 power 5. The value of n is ranging in between 1 to 20, and the sum of n over all test cases doesn't exceed 3 into 10 power 5. So we have discussed this statement in our last problem, so you can refer to that. And 𝗟𝗏𝗃𝗲𝗃𝗃 are ranging in between 0 and 1. So the strings are binary strings, so value of the elements in the strings are either zeros or ones for all I. Yeah, let's move forward. This is all about the problem. Let us move forward to the solution. So to understand the solution, let us take these cases. So in one case, there is a 1 in A, I mean at any position I, there is 1 in A and 1 in B. At any position I, 0 in A, 0 in B, 0 in A, 1 in B, 1 in A, 0 in B. So let's see. Now, if you have 1 in A and 1 in B, what can you say from this? It means how does it matter in increasing or decreasing your score? So if there is a 1, you should blindly increment your score. That is clear. So if it is a 1, we'll blindly increase our score. Now, if it is 0 and 0 in both A and B at any position I, we should blindly take 0 in your score. Right? Coming to this case, if there is a 0 in A and 1 in B, you have two options, either incrementing your score or leaving your score as it is. So what will you do? In this case, we can simply check. To make your score odd, what will you do? If your score is already odd, I'll simply take 0 if it is already odd. Now, if my score is already even, to make it odd, I'll pick this one. So you're having an option in this at this case. So this is the important case. So these are normal, but this is a catch in this problem. Be it this or be it this. Got it? So this is a core part of the logic. This is going to decide whether you can make odd or not. Let's see how. We'll take few examples. Let us see these examples. Now, as I said, if it is a 1 and 1, you cannot do anything to your score. So your score remains. We need to simply add 1. Now, if it is a 1 and 0, what will you do? We can check. If your score is already odd, what will you do? You'll pick 0. So I'm picking 0 from this. So I picked 0. Next, again it is a 1 and 1. What will you do? We'll simply pick it. Same. Again 1 and 1. Pick it. 1 and 1. We'll pick it. Now you have an option of either picking 0 or 1. Which one will you pick? That depends on your existing score. Now if your existing score it is even, what will you do? You need to make it odd. So to make it odd, we'll pick 1. So 1 is being picked. So you're having an option of making this to an odd number. So the thing is, if you have at least one such thing, you can make your score to either even or odd. That is one case. Because to make a number to even, to change a number from odd to odd, we can simply pick 0. To change a number from even to odd, we can simply pick 1. You'll pick only if there is an option. Fine. Let us understand the second case. So the output for this is yes. Coming to the second case. You have 1 and 1. So your score will be incremented by 1 time. Again 1 and 1. Score is incremented by 1 time. 1 and 1. Score incremented by 1 time. 1 and 1. Score incremented by 1 time. So we incremented because there is no option. Blindly we should take 1 from this. Now finally your answer is even. Here. Now, can you make this even number to odd number? Is it possible? No. Because this is not a chance. There is no chance of either picking 0 or 1 in the forward cases. So the output for this is no. Now coming to the third case. Same. If you have 1 and 1, you will simply increment it. And 1, increment it. 1 and 1, increment it. 1 and 1, increment it. 1 and 1, increment it. Now the final answer is 5, which is odd. So even if you don't have any option of either picking or not picking, blindly if you pick anything, the number is odd. So in this case, the answer is yes. That's it. So coming to the logic. So what we can do is, we can check the minimum score. How is the minimum score dependent? So minimum score is dependent on such cases. The minimum score is if if AI is equal to 1 and BI is equal to 1, we'll blindly increment or sum, or let's take minimum sum. We increment it. Now to make this minimum sum to either even or odd, we must have at least one such case. One such case is enough. If there is no such case, then you cannot make this minimum sum to odd. Got it? Same like this. So in this case, our minimum sum is 1, 2, 3, 4. So your minimum sum is 4. To make this 4 to, what is this 4? This 4 is an even number. We need to make it an odd number. So to make it odd, we must have at least one such case. We have at least one such case. So we can make it. So the output is yes. In this case, the minimum sum is 4. But do you have at least one such case where AI is 0 and BI is 1, or AI is 1 and BI is 0? No such case. So you cannot make it as odd number. But here already the minimum sum is 4. Sorry, already the minimum sum is 5, which is odd. So since it is already odd, it is yes. So this is all about the solution. So the main catch is the minimum sum and such cases. Let us move to the coding part. So according to the input format, we'll read the number of test cases and iterate the number of test cases. And for every test case, we are having the size of the strings, size, and for every test case, for every test case, after the size of the string, we'll read A, then B. Now, as I said, we need to maintain the minimum sum. Let's take it as minimum sum initialized to 0. Then let us take difference. Difference is nothing but the number of cases where we are going to have either a 0 or 1 in AB. Next, we will iterate on both the strings using I. Now, check if A of I is equal to 1 and B of I if it is equal to 1. So this is going to increment your minimum sum. It is mandatory, you are not having any option here. Else, okay. Other case, if A of I is equal to 0 and B of I if it is equal to 1, you can increment your difference. One more case, if your A of I is equal to 1 and B of I if it is equal to 0. In these cases, yeah, seems good. Increment your difference. Now we'll check if your minimum sum. If your minimum sum is already odd, if it is already odd, then we need not take anything. So it is already odd, we'll not take anything and we'll print yes. Else, if your minimum sum is even, and if your minimum sum is even, you need to have at least one case like 1 0 or 0 1, which is dependent on this difference. So if your minimum sum is even and your difference is at least one. I'll take, if your difference is not equal to 0, then I'll print yes, else we'll simply print no. Yes, so we got the expected output for these test cases. Now we'll submit the code. And that's it. Let us move forward to the fourth problem, binary removals. So you are given a binary string s of length n and two integers x and k. So you are given binary string of length n. This is the binary string, and you are given two integers x and k. Your task is to empty the string by performing the following operations. So our main task is to empty this string. So it should be empty. Let's see what the operations are. In one operation, you may select any subsequence of the string such that the number of inversions in the subsequence lies in the range 0 to x including 0 and including x, and it is divisible by k. So the number of inversions should be divisible by k, and it should lie in the range 0 to x including 0 and x. And we can remove the selected subsequence from the string in one operation itself. Now our task is to determine the minimum number of operations required to empty the string. So before understanding it better, we'll move forward with the definition of a subsequence. So as given, a string t is a subsequence of another string s if t can be derived from s by deleting 0 or more characters without changing the order of the remaining characters. So let us understand this. We'll take this. This is a string s. So let's say there is some t. T is a substring of the given string if it is found by deleting some characters. So from the given string, I'll delete this, I'll delete this, and I'll delete this. If I delete this, what is t? 1, 1, and 1. And the order should be maintained. We have maintained the order. The order is same. On the other case, we'll take one more t, the subsequence. Now I'll remove this, this, and this. Now the subsequence is 1, 0, and 0. So for the given string, there are lot many subsequences. One such subsequence is this, and the other is this. So you can remove these if the number of inversions in the subsequence lies in this range and it is divisible by k. So let us understand about inversions. So inversions is nothing but an inversion in a binary string s is a pair of indices such that I is less than j and s of I is equal to 1, s of j is equal to 0. For example, the string s. So let us take this string 0, 1, 0, 1, and 0. So it is having 1 based indexing 1, 2, 3, 4, 5. Let us count the number of inversions. If you observe, it is shown that I should be less than j and s of I should be 1 and s of j should be 0. So if you observe, you have this. If you call this as s, and let's say this is I and this is j. Here I is less than j and s of I is 1 and s of j is 0. This is one inversion. So 2 comma 3 is going to form an inversion. One more inversion. If you take this as I and this as j, 4 comma 5 is also going to form an inversion. Still any other case, if you take this as I, sorry, this as I and this as j, I is less than j and s of I is 1 and s of j is 0. So 2 comma 5 is also going to form an inversion. So for the given string, there are how many inversions? 3 inversions. So this is all about inversions. Let's move forward. So our main motto is to determine the minimum number of operations required to empty the given string. We need to empty the given string. Got it? Let us move to the input format and output format. So the first line contains an integer t, the number of test cases. So the number of test cases, for each test case, you are going to have three integers, n, x and k. So n is the length of the string, x we have seen where x is going to be useful. So this is the case. K, yeah, we'll understand more about this in future. So this is n, this is, so this is n, this is x and this is k. And the second line is going to contain the binary string. So this is a binary string, yes. And the output format is the minimum number of operations required to empty the string. Let's see. And the constraints, t is less than or equal to, t is greater or equal to 1, less than or equal to 5 to 10 power 5, n is greater or equal to 1, less than or equal to 5 to 10 power 5, k greater or equal to 1 and less than or equal to 10 power 9, x is greater or equal to 0, less than or equal to 10 power 9. And the sum of n over all test cases doesn't exceed 5 to 10 power 5. We have discussed this statement in our second problem. You can refer to that. So let's move forward. We'll understand the example test cases. We'll start with this. Let us understand the sample input and output. So this is your given string. So for a given string, our main motto is to empty this string. Now, can I simply remove the entire string? That is one case, right? Because entire string is also a subsequence of itself. Can I simply remove it and empty it? No, because there is a case. You can select the subsequence such that the number of inversions in the subsequence lies in this range. Now, our range is nothing but 0 to 2. The number of inversions in that particular subsequences should lie in between this range, and the number of inversions should be divisible by 1. Let's see. So in this entire string, what are the number of inversions? So if you observe, if you consider this as I and this as j, I is less than j and s of I is 1 and s of j is 0. So the number of inversions is 1. 1. Is it lying between 0 and 2? Yes. And 1 is divisible by 1. Right? Both the cases are satisfied. So can I simply remove it in one operation, entire string? Yes, it is possible. So I'll remove the entire substring and one operation, and the output is 1. So the output for this is 1. Fine. Let us move to the second example. Now in this case, can I remove the entire string in one operation and empty it? Let's see. So we'll first check if the number of inversions is less than, if the number of inversions lies in between 0 to 2. So we'll count the number of inversions. How many inversions? So we can take a 0. We can fix this as some j. This can be an inversion, I less than j. So this is one inversion. With respect to this 0, how many inversions? This is an inversion, this is an inversion, this is an inversion. So 3 inversions with respect to this 0. Now coming to this 0, how many inversions? If you consider this as j, your I can be anywhere. I can be here, I can be here, I can be here, I can be here. With respect to this 0, 1 inversion, 2 inversions, 3 inversions, 4 inversions. So the number of inversions with respect to this 0 are 4. So total there are 7 inversions. Inversions are 7. Now this inversion should be in the range 0 to 100. In the range? Yes. But coming to the second case, it should also be divisible by k. Now here your k is 2. Is it divisible by 2? 7 is not divisible by 2. So this is not satisfied. Now in one operation can we remove this? It is not possible. So what are we doing? So we have seen that removing the entire string in one operation is not going to work because the number of inversions are 3 with respect to this 0, 4 with respect to this 0. So total number of inversions are 7, which is obviously in the range 0 to 100, but it is not divisible by 2. So this is fine, but this is not fine. So we cannot empty the particular string in one operation. Then how? So simple. We need to check for other subsequences. Let's say I'm going to pick this. Is this a valid subsequence? Let's check. The number of inversions with respect to the 0 are 2. So 2 inversions, and 2 is going to lie between 0 to 100, and 2 is divisible by 2. So both are satisfied. I can comfortably remove this subsequence. Fine. Now if I remove that, what is the leftover string? It is 1, 1 and 0. If you observe, this is similar to the previous subsequence itself. So we can comfortably remove this as well because it will satisfy both the conditions. In how many operations did we do this? 2 operations. Fine. So the minimum operations required to empty this string is 2. Is there any other way to empty the string? Let's see. We'll take the same string. So for the given string, can I say that this part is a subsequence of the given string? Yes, it is a subsequence. I'll remove the zeros and I'll get this subsequence. So 1, 1, 1, 1. Working fine. Can I remove this? Yes, because the number of inversions here are 0. 0 is less than or equal to any value of x. I mean 0 is going to lie in between 0 to 100 in our case, and 0 is divisible by 2. Both are satisfied. Can I remove this? Yes, I'll remove this. If I remove this, what is the leftover subsequence? 0 and 0. Can I remove this? Yes, because the number of inversions here are 0 and it is satisfied, and this is also satisfied. So I'll remove this. So how many operations did I take? 2. But I did not take such subsequences. I took another subsequences. Any observation? So if you observe, at max, how many operations will any string take? Be it any string, 1, 1, 1, 0, 0, 1, 0 or 0, anything. Let's take this string. So can you remove this entire string? Check number of inversions with respect to this 0 or number of inversions is nothing but number of ones present on the left, guys. So 3 with respect to this 0, it is 3. With respect to this 0, it is 4. With respect to this 0, it is 4. So this string, total number of inversions are 3 plus 3 is 6, 6 plus 4 plus 4 is 8. So it is satisfying this case. But what if It is satisfying the case like 0 to 100 and it is divisible by 2. So we can remove the entire string. Fine. But what if I give you 0 here? If I give you a 0 here, will it work? With respect to the 0, one more inversion. So total number of inversions are 6 plus 8 plus 1, which is 15. Is it divisible by 2? No. But if you observe, I can take two subsequences definitely. What are two subsequences? 1, 1, 1, 1. Then this is a subsequence which will satisfy any case, this case and this case, because number of inversions are 0. 0 is less than or equal to 0 and 0 is divisible by any number. So this is a valid subsequence. I'll remove this. If I remove this 0, 0, 0, 0, 0, I can remove this as well comfortably. So how many operations did I take? 2. So we can conclude that the answer for this problem is going to lie in between 1 and 2 itself. It is either 1 or it is either 2. When is it 1? We'll remove the entire subsequence if it is going to satisfy these two cases. If it is not going to satisfy these two cases, we'll remove all ones in one operation and in the other operation we'll remove all zeros, because all ones can be removed because number of inversions will be 0. All zeros also can be removed because the number of inversions will be 0 in the both cases. If you observe, you are given like 0 and x, means the number of inversions can be 0 and a number is divisible by 0. Sorry, 0 is divisible by any number. My bad. How do you find the number of inversions in the given string? Let's see. So inversion is nothing but if you have any value of j. So j should be, your s of I should be 1 and s of j should be 0 and I should be less than j. So for this, let us fix the value of j. You'll fix the value of j and you have multiple I values which are less than j. So what are we doing here? This can be some I, this can be some I, this can be some I. All these i's are going to contribute the number of inversions with respect to this particular 0. Similarly, with respect to this 0, one more I'll add here. This is a j, this ij, this ij, this ij, this ij. These are the number of inversions. So basically, the number of inversions is dependent on 0. So it is nothing but the number of ones on the left of 0 is equal to the number of inversions. Got it? So number of ones on the left are going to contribute the inversions for particular 0. So for this 0, 3. For this 0, 4. So this is how we are going to find the number of inversions. So to find the number of inversions, let's say we are going to have let's take prefix ones. Prefix ones in that sense, the number of ones on the left. At any point, you're going to get the number of ones on the left, including that particular index. So I'll write it as number of ones on the left till I, including I. If we take this, let us have this prefix ones. here. So number of prefix ones here, it is 1, here 2, 3, 3, 4 and 4. So if you have the prefix ones for any value of I, what will you do? Whenever you find a 0, you can include these number of ones into your inversions. So your inversions will be, if it is a 1, there is no inversion, no inversion, no inversion. But if it is a 0, it is going to include the number of ones on the left, which is nothing but 3. So 3 inversions, here 0 inversions, 4 inversions. So adding this, 3 plus 4 is equal to 7. This is how you are going to get the number of inversions. Fine, I hope you understood how we are going to calculate the number of inversions. You'll understand it better while we are coding it up. Let's move forward. Let us move to the coding part of binary removals. We'll start using the input format. So the first line is obviously the number of test cases. We are looping over the number of test cases. Next line is going to contain n, x and k. So we'll read it. Then we will read the string. Next step, we need to count the number of inversions on the entire string. So for that, let us initialize inversions to 0. Then we also need to maintain prefix ones initialized to zeros. So we'll calculate the number of prefix ones. For that, we'll iterate on s. Now, if you find if your I is equal to 1, increment your prefix ones. Else, it is 0. If it is 0, it is going to contribute the number of inversions. What are number of inversions? Number of inversions are nothing but the number of prefix ones. So finally you got the number of inversions. Now, if your inversions are less than or equal to x, if it is less than or equal to x, and if the number of inversions is divisible by k, then we can remove the entire subsequence. So we have counted the number of inversions in the entire subsequence using this logic. So if this is satisfying, we can remove the entire subsequence. So we'll print 1. Else, if it is not satisfying, we'll remove zeros. We'll remove the subsequence with all ones, we'll remove the subsequence with all zeros in 2 operations. So we'll print 2. Let's run it. So we got the expected output and we will submit. That's it. So that's it for today, guys. Thanks for sticking till the end. I hope you found the video solutions helpful. If you found them helpful, do like and share it with your fellow coders. And if you want to receive more updates on the latest coding, contests and solutions, do not forget to subscribe our YouTube channel. Until then, keep coding and keep improving.